Okay, for the second class, we're going to stick with trigonometry and we're going to work through a few more of the applications. So this is page 78 of your trigonometry notes, of your notes booklet. Page 78, if you want to find that. And it's the second example of applications. So if we look at this question, they have tan of a plus b. So straight away, I think we can guess that we need to use our tan of a plus b formula. So tan of a plus b is equal to, let me just look it up. Tan of a plus tan of b all over 1 minus tan of a tan of b. In terms of filling into this formula, we know the value of tan of b, we don't know the value of tan of a, and we know the answer. So this is kind of a working backwards question already. We're going to start by saying that tan of a is x, just to make it a little bit easier. So we'll say that tan of b is 3. Tan of a, we're just going to call it x for the moment because that's what we're looking for. And tan of a plus b is equal to 4. So this will be 4. This will be x. This will be 3. 1 will stay as it is. This will be x. And this will be 3. And we fill into the formula. So filling into the formula, we get that tan of a, x plus 3 over 1 minus tan of a, x times 3. I'll just write it like this. 1 minus 3x is equal to 4. And I'm going to write it as 4 over 1 because now I can cross multiply. I have two fractions either side of an equal sign, and I'll do x plus 3 times 1. 1 by x plus 3 equals 4 by 1 minus 3x. And I'll multiply out my brackets and bring everything to one side. Not everything to one side. Letters left, numbers right. So x plus 13x is equal to 4 minus 3 plus 12, sorry. I did the adding as I moved it. So 13x is equal to 1. And x is equal to 1 over 13. So my answer here is that tan of a is equal to 1 over 13. I don't know why we left so much space for this, it didn't really need it. Okay, so figure out what formula we're using, fill in the parts, and we can work backwards from there. We're going to move on to page 79. And this kind of question is a little bit more difficult. They tell us cosine of twice an angle, and they ask us to find two values for cosine of a without using a calculator. So, of course, we have our formula, our cos 2a formula. We know that, so we're probably going to be using that, right? Let's write it down. We're going to use the fact that cosine of twice an angle is cos squared the angle minus sine squared the angle. And we just proved that today, and that's on page 14. And you can have your log tables open in front of you to mix and match and find the right formula to use. Now, the problem with that is we don't know what cosine of the angle is. We only know what cosine of twice the angle is. So what are we going to use? So we could use that this is 1 over 49, but that's not really helping us. Okay, so this isn't a helpful formula to use. Not helpful because there are two things we don't know. We don't know cosine and we don't know sine. So what are we going to do about it? Well, you can look in your log tables 14, 15 and 16 and you'll see that there's a whole bunch of other formulas to use as well. And as you go through it, you'll see that there's another cosine 2a formula. So cosine 2a is also equal to 1 minus twice sine squared a. And that can be equal to 1 over 49. And why is this better? Because we only have one thing we don't know. So this is better because there's only one unknown. Okay, so we can work with this. But how do we do it? So, first of all, let's manipulate our formula here. I find it easier to work with something, let's call it x. So we'll say let x equal to sine of a, and then x squared would be sine squared a. Just makes it a little bit easier to read the algebra. So therefore, 1 minus 2x squared is equal to 1 over 49. And we can put that over 1 because now we can cross multiply. So 49 by 1 minus 2x squared is equal to 1. And we'll multiply out our brackets. 49 minus 98x squared is equal to 1. And we'll bring things over to the other side. So minus 98x squared is equal to minus 48. And x squared is going to be minus 48 over minus 98, or x squared is equal to, and put it into your calculator, it's not quite a half, but it does simplify. The minuses will cancel, and that's the same as 48 over 98, which gives us 24 over 49. 24 exactly? 24 over 49. So, where do we go from there? That means that sine squared of a is equal to 24 over 49. But if I was solving this, I'd solve for x and I would square root both sides. So that's one fact. Therefore, sine of a is going to be plus or minus the square root of 24 over 49. And my calculator will do the work for me there. Over 49, which is 2 root 6 over 7. That's great. I found sine of a, but that's not what I was asked for. I was asked to find cos of a. I was asked to find cos of a. So, and it's plus or minus, so I've got two values. That's good because they did ask us for two values. 2 root 6 over 7. How do you find cosine when you know sine? Now they said not using a calculator. So of course we could do sine inverse. And if you were really stuck, you might as well do that because you'll get partial credit for it. Use the calculator if you get stuck. But how do we do this without a calculator? Without a calculator, you need to draw a triangle and use opposite over hypotenuse. So without a calculator for these kinds of questions, you need to draw your right-angled triangle, my angle A down here, and my opposite over my hypotenuse, 2 root 6 over 7, and then I can use Pythagoras to find the missing side down here, the adjacent. So we use Pythagoras. The opposite squared plus the adjacent squared is equal to the hypotenuse squared. And from that, we get 2 root 6 all squared plus the adjacent squared is equal to 7 squared. So a squared is 49, squaring that out, minus 24, which is 25. So my adjacent is going to be 5, well, plus or minus 5 when I'm doing my cosine. And cosine of my angle is adjacent over hypotenuse, so that's going to be plus or minus 5 over 7. And those are my two values. Okay, pretty complicated question there. I wanted to show you how just because we've got one formula, it doesn't mean that it's the right one to use. If you go down a wrong path, which you quickly might do, hopefully you'd realize that you can't do anything with this because there's two unknowns, so we can't solve that. So look through your formulas, and there's a second formula with cosine of 2a, and this is better because there's only one thing we don't know. And then you can solve this using algebra. It's like a quadratic equation. You get two values because of the squared, so it's plus or minus. That's where the two values are coming from there. And if you know sine and you're looking for cosine, so when you know sine and you're looking for cosine, you draw the right angle triangle and use opposite over hypotenuse, adjacent over hypotenuse, or if we were looking for tan, opposite over adjacent. With Pythagoras' theorem, we can find the third side, and therefore we know cosine of the angle. So a question like that will be worth quite a lot of marks. There's a lot of things to remember when you're going through it. Okay, I'm going to leave it there for tonight. Excuse me. The only homework that I want you to do is understanding the question. So what I would recommend is that you would try to do this question after you've gone through the notes. Try to do this question without your notes and see if you can do it yourself. Okay, thank you.